Okay, our first process for finding a 3 by 3 determinant very much mimics the 2 by 2 determinant process where we're doing cross products and subtracting. We just have to do a lot more of them. So for this first method, we have our 3 by 3. In order to make it easier to use with the diagonals, we're going to rewrite. We have columns 1, 2, 3. We're going to rewrite column 1 over to the other side, so 2, 4, 2. And then we're going to rewrite column 2 over here. So we have 1, 7, and 4. So we should end up with 5 columns, 3 rows. Now the way this is going to work is we're going to draw 3 diagonals in both directions. So we're going to start up here at the top left, and we're going to multiply across the diagonal. So we're going 2 times 7 times 0. Now we're going to go over 1. Do that next diagonal. So plus 1 times negative 2 times 2. And then go the next diagonal. Plus negative 1 times 4. Times 4. So we're going to add all those up. And now we're going to draw backwards diagonals and subtract those. So this is going to be a subtraction sign. And then we're going to subtract this whole process. So start at the top right this time and go backwards. 1 times 4 times 0 plus 2 times negative 2 times 4, running out of room, plus negative 1 times 7 times 2. And we're going to subtract that whole piece. So now it's just a matter of multiplying, adding, subtracting. So we have 2 times 7 times 0 is 0, plus 1 times negative 2 times 2 would be a negative 4, plus negative 1 times 4 would be negative 16. Now we do this next part. 1 times 4 times 0 is 0. 2 times negative 2 times 4, that'd be negative 4 times 4, so negative 16. Negative 1 times 7 times 2 would be negative 14. Now we get our two sums. Negative 4 plus negative 16 is negative 20. Subtract. Negative 16 plus negative 14 would be negative 30. Negative 20 subtract negative 30, that turns into a plus. And our determinant is just 10. So now this is just one option. If you don't like this one, then maybe you'll like the next one better on this previous slide. Okay, the second method is going to break the 3 by 3 matrix into 3 separate 2 by 2 determinants, which are easier to solve. So it's going to use something called cofactors. It means is we're going to essentially cut off this top row, and these top numbers are going to be what we're going to call our cofactors. So to work with this way, what we're going to do is we're going to start, take number on the top left, and 2, and we're going to multiply that number by the determinant. I always like to think of these as the catty corners of the bottom right 2 by 2. So we're going to then multiply this by the determinant of 7, negative 2, 4, 0. Now we're going to move to the next cofactor. So let me switch colors. Our next cofactor, just over 1, is going to be our 1. And now for this middle number, we always switch the sign. So we're going to say subtract 1. And we're going to multiply this by the determinant. This is the harder one to see, of the outside. So essentially you're going to cover up, and I'll show you this more tomorrow, cover up the rest of that column under 1, and we're going to multiply this by the determinant of 4, negative 2, 2, 0. Now we're going to go to our third cofactor, which is just the third number on the top. This sign stays the same, so it was minus, stays minus. Subtract 1, and we're going to multiply this one by the determinant, again, catty corner, of what's left. 4, 7, 2, and 4. So it breaks the top level up. All 3 of these coefficients are your first or your top row, and then you get these determinants essentially from what's left. So now we just have 3 2x2s to do, and these are a lot easier. So we have 2 times, do 7 times 0, minus 4 times negative 2 gives us negative 4 times negative 2 is a positive 8. Minus 1 times, determinant here, 4 times 0, minus 2 times negative 2. Negative 2 times negative 2 is a positive 4. And then minus 1, again, determinant here, 4 times 4, minus 2 times 7. So we get 16 minus 14, which is 2. Now we just do 2 times 8 is 16, minus 4 minus 2, and we get that our determinant is 10. Same thing we got on the previous slide. So I have no preference which of these methods you use. It's whatever one makes most sense to you. And we will go through them again tomorrow so I can show you visually kind of how this is working. But if this didn't make full sense to you, rewatch this video again, just to get an idea of how these 3x3s work. And for the final part of tonight, go ahead and try your best to do the 3x3 determinant on that final slide in your notes.